Okay, so we left off on talking about the standard reduction potentials. And so let's take a look. If you could take a minute to write down the following ones. Write down this equation for silver, this one for Fe3 plus. Write the chlorine one down, but put them in order. So start with the chlorine, silver, iron, and then also do Fe2 plus. Okay, so let's just recap the importance, because this is a really important one, that up here at the top, Fe2 wants to be reduced. How do we know that? Is because it has the most positive reduction potential. Okay, that's the most positive reduction potential. Down here at the bottom, lithium. Lithium wants to be oxidized. It has the most negative reduction potential. All right, so down here at the bottom, this one wants to be oxidized. That makes it the stronger reducing agent. The top wants to be reduced. Those are the stronger oxidizing agents. Okay, so if you could pause me then and write the ones that I highlighted in red so that we can talk about them on the next slide. Okay, so let's say we want to build an electrochemical cell voltaic cell with silver and let's do iron 2. Okay, so the numbers from your chart that you wrote down look like this. Silver, these are all both going to be reductions because they're from the reduction potential chart. That 8 looks weird. Okay, then the iron. That is negative 0.44 volts. Okay, for a voltaic cell, somebody has to be oxidized. So the more negative now, it doesn't have to necessarily be a negative number. It just has to be less positive or the more negative. The more negative potential is oxidized. And we're going to flip that reaction. So what I mean by flip is that I'm going to keep the silver as a reduction. And I'm going to flip the iron to an oxidation. When I flip that, I've changed the sign. Okay, so now I have the 0.80 is the reduction, and I flipped the negative 0.44 to plus 0.44. And so now I'm going to have a new cell, the cell potential for the overall voltaic cell This guy is going to be, we're going to add him to 1.24 volts. Okay, adding on to this. Who's going to be the anode? Anode is oxidation. Who's the cathode? Cathode is the reduction. Who's the oxidizing agent? Well, oxidizing agents cause oxidation, so they're reduced. So silver ion is the oxidizing, oops, I didn't mean to do that. I was on a roll with my pretty pens. It's funny. Okay, there we go. So the one that's reduced is the oxidizing agent. The one that is oxidized is the reducing agent. And I meant to write cathode here, sorry. Okay, now if I was going to draw this as a voltaic cell, then what I would do is I would go ahead, I'm going to get a black colored pen. So I'm going to have a beaker here. It would have the anode, a piece of Fe with Fe2 plus in the solution. The electrons would flow from the anode to the cathode. And then on this side, I'd have a piece of silver. In the solution would be silver ion, salt bridge, and then that's going to produce that current coming across. Okay, one last thing. When we look at the overall equation, the number of electrons lost has to equal gain. So I'm going to have to multiply that top equation through by 2. This is one of the few properties, though, that does not change the value of the voltage. So this is going to look like this, 2Ag plus Fe solid goes towards 2Ag solid and Fe2 plus. And there's my cell voltage. This is very, very important. So you need to know how to do this for your test. Let's try one more. Okay, so the reduction potentials from the table, also in the back of your text. Okay, so let's see where we're at. The more positive potential will be reduced because it's more positive. This one is going to have to then be flipped. So the higher it is on that chart, if they're in order of plus, which they usually are, the more positive ones are at the top, those stay reduced. And so Fe, this one will get flipped. Okay, so I'm going to keep the chlorine. When that gets flipped, it goes to negative 0.77 volts. Okay, so somebody has to get flipped. It's always the one that's um, less negative. Less negative. I'll pick a different color for the other one. Oops, I made a mistake here. When I flip it, it goes to oxidation. Okay, things are going from bad to worse. Okay, so we're going to add those two together. Now, what would have happened if I had picked the wrong one to flip around is I would get a negative cell potential, and you can't have that for a voltaic cell. Voltaic cells always have to be positive, right? So I could not have flipped the negative, made the 1.36 negative. That would have created a negative cell. So this should be E of cell will be plus 0.59 volts. When E of cell is positive, that cell is spontaneous. Okay, and then these guys here, we now can add up. This has to have 2 electrons. Okay, so you have chlorine plus 2 Fe2 plus to 2 chlorides and 2 Fe3 plus. Okay, if I was to write somebody and draw the picture of this voltaic cell, okay, the iron 2 is our anode because it's being oxidized, and the chlorine is the cathode. Now, let's look closely. The iron isn't iron metal, it's iron 2 to iron 3. That's going to need that inert electrode of carbon. And in the solution will be iron 2 and iron 3. Salt bridge. On this side, chlorine and chloride, again, will need an inert electrode. Chloride will be in the solution. Now, normally, this one's harder to draw, so you'd end up having the inert electrode, and I made that too wide, having the gas pumped into this. Normally, I don't have you draw that style. If you look on the prettier picture on the previous PowerPoint, then or a video lecture, it'll show it as a platinum wire, usually with the gases. But anyways, you get the point here that you need the gas to come in, be pumped in, you need the inert electrode, and then that's in contact with that solution. Okay, and that cell has a positive voltage because when E of cell is positive, it's spontaneous. So we always have to flip one. And going back, let me go back. Okay, if we have on this chart when they're in order, so let me show you. So this one here, I'm comparing this one to this one because this is more positive, that stays reduced. This one gets flipped. Between this one this one stays reduced, that one gets flipped. Okay, so that is really important because as you go down and they get more negative, they're going to be oxidized.